Yeah, so we're just going to write it down with the fractions in a one above the other like that, first of all. Right? So what we need to do is look at the denominators of each fraction. We've got a 15, we've got a 6, we've got a 10, we've got a 2. We look at the bottoms of each fraction. Now, what we want to do, and I'm going to have you all just write these numbers as you got 15, right? You got 6, you got 10, and you got 2. We want to find a number that each of these, one number to where each of these numbers goes into it, right?
Yeah.
I mean, we could have just tried to get a common denominator for 6 and 15 and forget about the others for now, and that would help us along the way. But in any case, let's just look at 6 and 15. Let's just break them up. So 15, let's just look at 6 and 15. Let's just break them up. So 15 is what times what? What times what makes 15? Give me a couple of factors. Give me two numbers that multiply to give 15.
Match. I don't know, I'm blinking. 2? 2 times 2?
Yeah, 5 times...
5.
5 times what gives 15?
5 times 3.
Good. And then 6. Two numbers that multiply to 6?
3 times 2.
Good. Good. Perfect. So, and this can help us. So, this is another way of doing it. But what can I so I'm going to multiply this by something so that all of these numbers are included, if that makes sense, right? So I've got a 5 and a 3. Well, the 3 appears over here, but we don't have the 2. Does that make sense?
Yeah.
So I'm just going to write a 2 here. Right? And now I've got a 5, the 3, and I got the 3 and the 2 here. 3 and 2, right? And so if I multiply these three numbers together, that gives me what?
Oh, the 2, 5, and 3?
Yeah.
2 times 5 is 10.
Yep.
And then 10 times 3 is 30.
Yeah, that's 30, yeah. And with the 6, I can put what factor am I missing here? I got the 3, a 2, and I'm missing a what?
1.
A 5, right?
Yeah.
So 3 times 2 times 5. That also makes 30, right? Because it's 6 times 5, that's 30. Okay. So it looks like 30 is the magic number. Well, 15 will go into 30, won't it?
Yeah.
6 will go into 30. Will 10 go into 30?
No.
Yeah, because it'll be 10 times 3, right?
Yeah.
Right. Good. So 10 times 3 will give us 30. And 2 will go into 30 because that'll just be 2 times 15, right?
Yeah.
So in any case, we can rewrite all of these fractions with the same denominator. All right? So 15 times 2 gives 30. But if I multiply the bottom by 2, I must multiply the top by 2 in order to keep the value, the actual, quantity the same. So that is 1 times 2, 2 30ths. Because 2 30ths is the same thing as 1 15th, right?
Yeah.
Right. And so we do this down the line for each one. We convert it to fractions with 30 in the bottom, right? So we want to turn all the fractions into equivalent fractions with a denominator of 30, because that's how we can easily compare them and figure out which is more and which is less, right? So anyone watching from home, please press pause on the video and turn these fractions into fractions with a denominator of 30. So just press pause on the video and do that. Alright, so I hope you've all had a chance to do that. So turning this into 30ths, we need to go 6 times 5 to get 30. If I multiply the bottom by 5, I must multiply the top by 5. So 6 times 5 is 30. 5 times 5, 25. So in other words, 5 6 is the same thing as 25 30ths. This one, 10 times 3 is 30, and this one, 10 times 3 is 30, and multiply the top as well to get 30 on the bottom, and 7 times 3, 21 30ths. And then here I got to go 2 times 15 is 30, and multiply the top by 15 also to get 1 times 15. So this 1/2 is the same thing as 15 30ths. You okay with that?
Yes.
And so now we can see which is the largest and which is the smallest, right? And it says order from smallest to largest. So, okay, so which is the smallest?
The top one.
Right, so we got 2/30ths, that's the smallest, or 1/15, same thing, right?
Yeah.
And then the next smallest one is
15 over 30.
15 30ths, which is our half. So we'll write down a half. That's the next smallest one. And then 7/10ths, right? Because that's 21 30ths.
Yeah.
And the largest is 25 30ths, 5/6, right? And we could use the inequality just for fun because this means less than. Because the inequality sign, by the way, used to be an equal sign, but they took the two parallel lines and did that to make a point and a gap. Okay, because you know, I'll pick random numbers, but 7 is less than 10. So you can't say they're equal because 7 is not equal to 10, but you can say it's less than it. So you take the two parallel lines for the equal sign, and you just do that. You make a point here and a gap here. The point is beside the smaller number because the point is smaller than the gap, right? So point here, gap here. Anyway, so that's less than. In any case, so 15 is less than a half, and a half is less than 7/10ths, and 7/10ths is less than 5/6. So this appears in the back of the book. That's why I wrote that out with the inequalities. But you don't have to. But in any case, yeah, that's least to greatest, right? Great question.